Hey, hello. Welcome to Gotham Sound's live stream. We are here. I'm Peter. This is Will.
Hello.
We're here to talk about some of our interfaces that we've made for commercial products. There's been a pretty interesting trend, a combination of things. One, manufacturers have been opening up their APIs meaning application programming interface. And two, the tools for programming have come down in cost considerably, either free or very low cost. So I think that this is a kind of unique time to be putting together professional audio systems, because if there is not a function that the manufacturer has thought of, we're in a unique position to be able to conceive of it. So we wanted to talk about that stuff generally. We have some examples of some of what we've done, and we hopefully will inspire people to think about how they could modify their own products. I guess I should start by saying that I started, I got my first paycheck doing sound in 1986, and DIY was very much a part of it. It was expected that you knew how to make your own cables, or soon after being a professional sound person, you could make your own cables, make your own repairs to a large extent, and have a basic understanding of electronics. For better or worse, I guess I don't want to get too personal, but for better or worse, I was a latchkey kid growing up in New York City, and so that meant that I was able to combine my time unsupervised with computers. And so from a very young age, I began programming computers. And so I think part of what I hope we achieve today is there's a whole other generation of sound mixers that also are able to program as comfortably as they are able to type in a word processor. And I hope we can inspire them to take up this torch, or at least sort of think about and really challenge them for a way to make custom interfaces or modifications at the software level.
Yeah, I think a lot of the reason to do so is production has a specific need, and until we come up with a solution, there's not really a good, clean way of doing it. So a lot of this is kind of for the benefit of, producer listening stations, or creating individualized mixes, basically.
Yeah, I mean, let's talk about, so none of these were sort of programming for programming's sake, right? I mean, they all came out of a specific...
need, yeah.
A need. So let's talk about the first one, which is...
Right.
So this was a reality show that, we're going to avoid saying specific names of reality shows just because we don't necessarily have permission, and that way we don't run into any trouble. But call us and we'll talk about it in more detail. This was a show that had it had multiple inputs, something like 36 different audio sources, actually more like 39 different possible audio sources that needed to be able to be routed to any number of destinations, 8 different cameras. And so a traditional console, even a digital console, that would be challenging on. Digital consoles are great because they're, you can flip between different mixes quickly with the motorized faders, but they're still linear. And so you're still sort of looking at one mix at a time, basically. What this client needed was a way to look at 8 mixes at a time and punch people in and out really quickly. So as you can see here, there's different cameras. And in fact, there would be an operator sitting here with 8 different mixes. with
Camera
8 different
feeds.
camera
Yeah.
feeds, and each one would be people going in and out of the camera, and as those people were going in and out of camera, they would be able to choose those mixers. So if, for example, camera C, Homer, Marge, and Bart entered the frame, which is the new Simpsons reality show,
Yeah.
you would choose Homer, Marge, and Bart. This particular sound supervisor wanted red to mean it was passing audio. Again, these are all sort of choices.
Mileage may vary. Yeah.
But anyways, so it's that quickly. Similarly, if suddenly camera D were to get a close-up of Chief Wiggum, simply punching that was what you'd have to do. It'd be very quick. And as the sort of idea grew, there were a number of custom requests along the side. So they wanted a way to be able to clear mixes very quickly. So, we just sort of made these quick clear buttons here. And anyways, it sort of grew beyond that. And so this is a way to do that very quickly. Obviously, the show is such that the action is changing much more dynamically than what I'm describing. Do you want to add anything to that?
There's not much to add, really. It's just individualized mixes and another control surface for adjusting gain, specifically for the camera mixes.
Right.
Just a USB controller that's talking to this and telling, oh, Marge needs to come down, this much. So there's still an element of mixing being done even at this level, not simply toggling on things on and off, but actually mixing.
Picture a control surface similar to this. With knobs here. We've temporarily repurposed this, which we'll show a little later. But yeah. Thank you. The tool to use this is something called Isadora. It's a kind of graphical programming tool for, it was designed originally for choreographers and people doing live theatrical events. So if we sort of go behind the scenes here, obviously there's a touch screen, and if I hide the controls, you can see there's a whole sort of programming thing that's going on here. And you can dig down deeper, and you can see there's a whole programming thing going on there. So, it's really, I read a great thing by a professor at NYU, Tom Igoe. Programming is breaking down a complex problem into a series of logical steps. For me, it started with, if you think about programming in terms of logical steps, break down the steps to make a peanut butter sandwich. And you break it down into simpler and simpler steps. And so that's what Isadora is really great at, because it takes a lot of the syntax of programming, takes all the syntax of programming away, and you're just sort of connecting the dots.
A lot of internal logic that you don't have to see, that a producer can intuitively, or anyone can intuitively see there's a mic on or off on a camera.
Right. And so I think that's the first interface we wanted to show. And so that ends up controlling Automixers. Electrosonics, like most of us know Electrosonics for their wireless, but they have a whole other division that makes audio mixers. And those audio mixers were originally designed for courtrooms and for places where audio levels aren't really likely to change and you don't need a surface. So originally that's what we were using. But one interesting thing that comes out of programming is you can absolutely abstract the audio interface. And what I mean by that is, because the electrosonic stuff was not meant to have so many audio inputs dynamically changing, there is a bit of a lag. But we're slowly moving over to the Behringer line of mixers. And Behringer has a rack mount mixer with no controls that is very, very responsive. So that's one example of that.
Yeah, controlling that through Behringer's native OSC, which we'll get into a little more later.
Yeah. I guess we should move on to the second topic.
Yeah.
Any questions? Anybody? Any? Nope. Okay, good. So you know, we've also been using Dugan Automixers, and I got a call to do a show that was basically shot along the lines of the old Playhouse 90 stuff, where they, you know, they were doing it in one take or as close to one take as possible. It was many, many pages with many characters entering in and out. The sound supervisor of that show, who we hope to have on, and we'll talk more in detail about it at a later date, they had to use the Dugan D2 Automixer, and Jared, I think we have a still store of that, right? But anyways, the D2, yeah, there it is, Automixer. You know, they were locked into it. I was only a guest A1, so I couldn't make a lot of changes. And that sort of, there were a variety of reasons why, even though this was an older model, that's what they were going with. But one thing, and next week is really when we'll delve into auto mixing. But one thing I think to keep in mind is, you know, auto mixing is not simply you dump all of the audio into this thing and then just sit back while it does its mix. It needs to be guided. And especially just think about practical things like a character or an actor is waiting in the wings before they are part of it. You know, it would be, it would really increase the noise floor and have the potential to kind of screw up the automix algorithm if actors and characters were left needlessly in the automix algorithm. So one thing about this show, the entrances and exits were so quick that we really did want to come up with a way to automate this. Now, because in all of Dan's products that he makes, Dan Dugan, he publishes an API. And so we were able to come up with a way, and I'm just going to call up my QLab here to have automated cues. There we go. So, for example, I can control the Dugan Automixer simply by firing off these cues. So as different characters come in and out, we can sort of direct the Dugan to pull them in and out of the automix. Whereas previously, and Jared, if you can go back to the D2 still store for me. Previously, if you look on that remote control, it was sort of punching those buttons, and there were 16 characters. So, you know, this was where I was the client, and I realized that I wouldn't be able to punch all those buttons and keep up with the script. So, you know, we came up with this sort of automated thing. QLab is a program, again, it's designed for live theater. So, you know, the stuff that we look for, when it says it's designed for live applications, where
how can we repurpose that?
Yeah, how can we repurpose
ends?
It also means like it's probably pretty solidly built if it's designed for live applications. So yeah, so we were able to use that, and then if you can, yeah, there we go. So if I move that out of the way, again, we have Isadora behind the scenes translating these QLab calls into serial commands for the Dugan to change. And then also we made a little control interface so that if need be, we can take over. You know, sometimes they might change something that's not in the queue, or they might change something after a take, And so, we'd be able to quickly put people into automatic or manual mode sometimes, or likely we would mute them if they were not part of the scene anymore. Remember, the Dugan automix algorithm, and a lot of automix algorithms, seeks to keep the noise floor similar between all of the mics that's part of its algorithm. So, the more you mute, the lower the noise floor becomes, if you don't need those mics, obviously. So that's another example of a custom interface that we did. We'll be talking about that in more detail in a future live stream. Do you want to talk about the third example?
So we've had a couple situations where we've had to create customized interfaces for controlling Behringer X32 consoles. This one is the full one, but we also have the rack-mounted one that doesn't have linear faders or anything. And for some of these larger shows, especially, producers want to be able to do their own kind of sub-mixes that they're just monitoring. And we have all these aux buses available in the Behringers. So essentially we wanted a way to use technology to quickly let producers manipulate those aux buses, You could just set up a station where everyone's monitoring and they have one sort of control surface to let's punch up Jerry on this mix. So they could do that without affecting the actual audio supervisor's work or A1's work. We do that through OSC largely with Behringer.
Right. We should talk a little bit about OSC.
Yeah.
OSC was invented at the University of California, Berkeley. It is effectively where every control that's a part of the OSC, as deemed by the architect of whatever product it is, essentially has a little web page. So like mix bus 1 might be /ch channel 1 / mix bus 1, if that's what we're looking to control, and then you'd give it a value. Human readable, easy to work with. Lots of programs support it. Isadora supports it, and then the program you're about to show.
Right. There is a mobile, an iPad or iOS or Android application called TouchOSC that lets us actually manipulate this from...
Should we put the sends on faders?
Yeah, let me put that on here. So this one is controlling aux 2 on this mixer. And if I pull this up, you can see the linear fader is actually moving. We're seeing that because it's just the sends on faders. This is just the aux. However, you're not limited to controlling auxes. This could be mapped however you need it to be for your project.
Right. I think there's...
Limited only by what OSC addresses exist per the hardware. For the X32, we have a pretty good idea what we can do with that now.
Yeah, the X32 is unique in the sense that every single parameter of the mixer is touchable by OSC. Mm-hmm. So if somebody wanted custom EQ controls, you could do that. If somebody wanted, we have a customer that wants gain knobs for the first 8 inputs. We could do that. Yeah. So this is an example of how to do it with a touchscreen. And one nice thing about a touchscreen like an iPad is we've had one producer who said, I don't want faders, I want buttons. Uh-huh. And even, I like that this could be buttons too. But yeah. So it's imminently, it's all doable, and it's only limited by one's imagination.
Yeah. In this case, we have it, we have the Behringer hooked up to a wireless router. The iPad's connected to that, and that's how it's able to interface. It's nothing really terribly complicated, and you can see it works to great effect. So, you would have this set up, you would have that aux going to a producer station where they could then monitor what they are mixing in real time.
And we had another client, and unfortunately I don't have the physical interface here, but I'll try and see if this will substitute. But they wanted physical faders. And so we got them a control surface by Behringer that has physical faders. At the last minute, we grabbed this and reprogrammed this just because that one with faders isn't available. But we made a little interface, and this is Arduino. So this is a microcontroller, and you can add various what they call shields to it. So this is a MIDI shield. This particular Arduino has an Ethernet built into it. And so it's simply, here, I'll switch over to bus. Wow, thanks. It simply lets us do a fader in theory. There we go. And control it from here. So there's all 8 faders going up. In addition, this particular customer wanted to be able to remap, like let's say they wanted fader 1 to control both 1 and Behringer input 3. Whoops, I managed to flip over there, so let's do that. So I just go down to one like that, and let's see, in theory, you're not going to cooperate. All right, let's see, 1 and 1. Just not going to work. All right, well, sorry for the last minute substitution, but that's the idea, is that you can sort of program these custom interfaces. So yeah, and again, Arduino, relatively inexpensive. The development software is free. Yeah, so any questions? Nope, all right. Well, that I think is going to be that.
That's a wrap.
That is, Tuesday, May 24th, we delve into Mix Assist on the 688, Mix Assist versus Dugan, and check out our Facebook and Twitter feeds for more. Archives are at Vimeo and YouTube, and as always, please send your ideas to info@gothamsound.com.